So, good afternoon. Our topic today is about the paradigm shift that IDCA and its notion of infinity paradigm is causing the data center industry. So I caution you, if you are a heart patient or suffer from diabetes or low blood pressure, the following might be disturbing to you. So IDCA was established to provide direction and give guidance to this community. It was established for the sole purpose of all the pain points that we have been witnessing over the past decades. All of us in this room can share many stories of where things go wrong, and therefore we decided to do something about it. My name is Mehdi Paryavi. I am the chairman and founder of IDCA. We formed this entity as an initiative to help all of us live and breathe in a sustainable industry. Everything you hear about cloud, IoT, big data, information technology, and data centers are what we relate to. And we are here to integrate them all and bundle them in a meaningful and purposeful manner. To accomplish the task, we couldn't do it alone. So we opened all doors to end users. We have put together practically the most comprehensive and diverse committee or consortium that has ever been put together in the information technology sector. We brought in the likes of LinkedIn, AIG, Major League Baseball, Time Warner Cable, NBC Universal, HSBC, the State Department, the US Courts, the US House, you name it. And once for all, we brought all of these people under one roof to speak one language and fulfill one purpose, and that is to unite the industry and fill the gaps that currently exist. We believe, and I personally believe, that this industry is the greatest industry mankind has ever created. There is vast potentials, immense potentials, and we are just at the beginning of a big journey. Everything you and I do today is somehow linked to this industry, and the way we live is shaped and formed by this industry. So as I said, we are at the beginning of an evolutionary journey. We experience massive problems in diverse domains. And I'm sure if you randomly select 100 people from this crowd and ask them, are they running flawless infrastructure? Are they living in a flawless industry? Everybody will disagree. And many will give you stories of how they have seen pain, they have felt pain, and they couldn't find a venue to speak out and address those issues. We need to come up with immediate remedies to solve these problems. And I caution every one of us, everyone in this room, that we wouldn't be here together again a few years down the line if we do not address the issues today. This industry, while expanding at a very rapid rate, it is diminishing its quality at the same speed. So IDCA was established to do just that, to provide that insight, to bring everyone together, and to hear from all of you what you think is the next step ahead. The first problem we see in the industry is the complexity of it all. Data center is a beast. It's complex. It's diverse. It has so many different sets of components that are totally independent of each other in a different world. You have to deal with electrical, with mechanical, with cabling, with networking, with systems, storage, human resources, finance, admin, site, civil, architecture. All of them coming together under one roof to perform a unified set of services to sustain business resilience. Much of the problem is related to lack of effective education. There is not one university out there in the world that teaches people data centers. So all professionals have to either go through electrical degrees, mechanical degrees, software engineering degrees, IT degrees, and then somehow work their way up into designing, planning, and operating data centers. This is why people are coming to us. Okay? I can guarantee you 50% of the people in this room cannot feel safe to talk about anything outside their own background. So if you are here as a data center professional, but you come from electrical background, I can challenge you on cooling, and you will not feel comfortable. If you come from a cooling background, I challenge you on network. You will not feel comfortable. Whereas we should all be comfortable with all the components of data center to a degree. And because that certainty is not there, we don't speak the same language. We have our own biases. And we only feel good with the people who think like us. There is broad subject matter requirements. There is immense vendor influence. How many in this room are vendors? Please raise your hand. Quite a big portion. Vendors are driving, by no surprise, this industry. Not because they are against us or they don't care. No, they're for-profit businesses. But because we do not demand the right stuff. We're not educated enough to know what to demand. I wrote a blog about this, that supply and demand doesn't work in the way we think it works these days anymore. It's not like whatever is supplied to us is what we demanded. No. Vendors have figured that out a long time ago. If you spend enough time to brainwash your audience, they will demand what you want to supply. There is a lot of technology to choose from. There is not enough basis or content out there that is unbiased. If you wanted to design a data center today, if you wanted to operate one, where do you go? There is about 5 million pages of contradictory information out there that you have to work your way through and then somehow become creative and run your own facility in what you think is the right method. At the core of all this, there is a big lack of application-centric mindset. People don't design or build their data center around the application. They build the application around the data center. Okay? I want to remind all of us that it is called data centers. It is not cooling centers or power centers or cabling centers. It is data centers. If you go to any one of the legacy norm standards or bodies and you ask them to audit you, they will check everything that doesn't deal with data, and they stop at the level that you began to see some action with the data. Our definition, our government's definition of data center is anything above 500 square foot. Well, data center is not defined by square footage. A data center, to me, could be as big as a USB stick if it has critical information on it. I want to pose a question. How many of us here think that if there is a site somewhere out there that doesn't have to be up and running even 4 days in a row, is not considered a data center? How many think a site that doesn't need to be up and running all the time is not a data center? Please raise your hand. Nobody? Good. I'm impressed. A lot of organizations possess facilities somewhere in the desert, some container, few racks, that his sole job is to do some backup, recovery, storage, and restore. That doesn't necessarily need to be up and running all the time. But do you have mission-critical information, vital information that you want to make sure that they remain confidential and their privacy is not compromised? Sure. So security is vital here, even though availability is not as much. Do you have people going in and out of these facilities? Yes. So you must ensure their safety. So safety is important. Do you still pay bills for energy? Yes. So efficiency is important. You're backing up, so you want to ensure that your core site, when it's being backed up, you have enough resources and capacity to back up. So capacity is important. So availability is not everything when it comes to the world of data centers. But unfortunately, the prime factor that people consider is availability. And when you want to talk about a site that is not supposed to be as available, they immediately move it off the chart and say, that site is not our priority. Therefore, we get all these cyber attacks. Therefore, we get all these people killed in our facilities which are unsafe. And therefore, we end up paying billions of dollars in excessive energy loss that we shouldn't in this day and age. Too many buzzwords. In the previous conference that I was keynoting, someone mentioned PUE of 1.1, 1.2, and I go nuts when I hear these buzzwords. Okay? Terms like PUE are one of the most abused and misused terms in this industry. People don't even know what they're talking about when they refer to PUE. There is 2 different versions of PUE. There is 4 different subsets of it. Which PUE are you referring to? It's impossible by law of physics to achieve one PUE of 1.15. It's impossible. It's marketing. So this industry is astonishingly input-driven and not as much output-driven. Therefore, productivity is low. Now, I'm not here to bash our industry. I'm here to say why we do what we do and what is the solution for it. And I want to invite all of you to participate with us. And I refer to the fact that when one efficacy is not as important, that doesn't mean other efficacies are not important, and therefore we need a common language. The standard language in this room is English, is the English language. Imagine if all of us came here today with a different language. How would we even communicate? So look around you. You see cabling guys, power guys, cooling guys, networking guys. And all of a sudden, they're supposed to speak the same language. Using what content? Using what basis? Nobody knows. We're just following brochures. This is a fact. So there is rapid evolution in many areas, such as cloud, such as IoT. And there emerges a lot of new requirements, such as capacity on demand and so forth. I'm not going to read off the slides. But we all know that there is big trends, and we have a hard time catching up to those trends. In 2014, $1.7 trillion was lost due to downtime. And those are reported losses, tangible losses, not the intangible that most organizations are not capable of measuring. 86% of companies have experienced one or more instances of downtime over the past 12 months. 92.6% of data centers in this nation are considered inefficient. 50% of energy bills are related to inefficient power and cooling design. And 93% of businesses that have lost their data for 10 days or more have filed for bankruptcy. These are industry facts. So I'm not here to show you pretty pictures. What do we do about it? The common core problem is we have modern era requirements, but we follow legacy principles. I have taught countless classes. I have lectured thousands of people worldwide. And I have said to everybody in my operation classes, the first thing you do as an operation manager is you write the policy, and the second thing you do is you write the policy to reinvent that policy. Your manuals, your policies and procedures are your number one bottleneck when they become obsolete. And the content in this industry is obsolete. It doesn't make sense anymore. We're sitting here under one roof discussing parameters that deal with only one site and one facility, whereas the world is talking about cloud and virtualization, and applications are designed to not run on one single facility anymore. And the notion of core and DR is obsolete already. So how we've always done it? Well, the way you've always done it doesn't cut it anymore. It's a facilities problem, not an IT's problem. It's everybody's problem. This is where we exit. We check out when we don't understand each other, when we don't feel comfortable sitting in the room with the IT guys, and the IT guys don't feel comfortable with the facility guys. Therefore, we throw the ball to their court. My data center is certified 99 whatever % availability. Therefore, my application will be available. Wrong. The biggest cause of failure of applications is the application itself, which we don't check. Most data centers that you guys all deal with are oversized or undersized for the application that you're supposed to host. And the fact that when we do come and measure a data center, we follow a checklist. Oh, you got 2 generators? Good, 2N. Oh, you got N+1? Excellent. That's not how it works. You have to evaluate all the efficacies. If this generator will actually run, what's the active load? Who's going to run it? Having a Ferrari without looking at the driver is a big mistake. You need to be licensed to run a few megawatt facility. It's not a toy. People get killed and injured all the time. CFOs want to approve the budget. What else is new? Now, I want to be fair here to the CFOs. For as long as you cannot render facts, don't expect an increase in your budget. For as long as you go and say, I need a $50 million budget for my data center upgrade, without showing opportunity cost. So what will happen if I don't give you the $50 million? Yes, we've done the math, and we're going to be losing over the next 3 years $137 million if we don't invest this $50 million. Nobody does it. People just ask for budget, and they expect to get it. Don't expect your CFO to relate with you about generators and chillers and cabling and redundancy when you cannot convert it to the language they understand, which is currency. First reason, lack of education. We are one of the most uneducated industries in the world. I can bravely say it. I've taught enough people to tell you that. I don't care whether people come from 30 years of background or just started 5 months ago. We come with our own set of biases. Depends who was our coach, who's our team leader, which atmosphere we work in. Are we in healthcare? Are we in financial services? And therefore, that's how our mind is set up. That's how we're configured. The next big reason is lack of standards. You don't need a million standards. You need one that integrates them all, that tries to make sense of it all. It's asking too much for an engineer to sit down and read Bixby, TIA, Uptime, ASHRAE, Green Grid, all of them, and then try to make sense of them. That's not a one-man's job. That's not even a team's job. And then when you read them deep enough, you find too many contradictory stories and too many overlaps. So what do we do? And then you got your local codes too. Then you got your industry codes too. So you just stop or give up or hire a consultant who doesn't know better than you do to try to solve your problem. So we took some measures. We took concrete steps. Step one was education. We spent nearly a decade in educating people. We were the first people who did it. We're probably, I can bravely say, we're #1 globally. We've trained tens of thousands of people worldwide, certified them, and we've achieved 99.996% whatever satisfaction. Not because we're so good, because there's nothing else out there. Okay? If you expect to come to our course and learn how to configure UPS, you're coming to the wrong place. We're not going to teach you that. There are so many courses out there to do that. We're going to teach you how to make sense of all of them as a package, how to integrate one harmonic system and run an application ecosystem, how to live and survive in a data center atmosphere and fulfill your purpose as a designer, as a planner, as an operator, as a decision maker, as a technician. It doesn't matter which position you come from. We believe that from the CEO down to the janitor needs to be trained, because data centers are not a joke. Everybody needs to be on the same page, and we have done that. We have trained executives all the way down to janitors. All specialties, whether you come from mechanical, electrical, civil, architecture, marketing, finance background, you need to all speak the same language. These courses are engineered to absorb all of these different and diverse specialties and titles and work them up. And having a common language is the bottom line purpose. If you speak that language that your vendors speak, and your vendors speak the same language that your consultant speaks, then we wouldn't have any problem, would we? The second step we took was standardization. On April 25, 2017, the IDCA Technical Standards Committee released the AE 360. It's called the Infinity Paradigm. It is called Infinity Paradigm because it's causing a paradigm shift in infinite ways. By law of physics, I can prove to you that infinity is not a possibility, but it is a goal. The whole concept of this is not to put a glass ceiling on your head and this is your maximum potential. It's to give you the minimum and let you be free for whatever you want to accomplish beyond that. We believe that data centers and information technology are not events, they're processes. You're required to be continuously evolving and be continuously innovative for you to survive and sustain your business through the modern era. We are living in an age that everything is being updated real time. Data center of today shouldn't look like a data center of 6 months ago. Let aside writing a standard 5 years ago and trying to follow it today. Doesn't work. I can tell you by experience, does not work. That's why Google doesn't follow the big names in the standardization world. Facebook doesn't follow them. Why? Because there is nothing good enough out there that speaks their language. So, in short, now Steve is going to get into the details of this. There is 7 layers and 7 efficacies. At the very top of this pyramid is the application layer. Every organization will have one too many set of applications. Riding a set of platforms, your IaaS, your PaaS, your SaaS. Riding an array of computing resources. These are your logical computing resources, your virtualization layer. On top of your ITI, your actual physical IT infrastructure. riding your SFI, your site facility infrastructure, your power and cooling and cabling, embedded in your site layer, your building, your land. And then all your sites combined give you a topology. They make up your DCC, your data center cloud. So you have the logical aspect as well as the physical aspects. And all your layers have to comply to 7 efficacies of safety and security, operations, innovation, availability, efficiency, capacity, and resilience. By understanding this model, you will make your own life easier. You will find your own purpose in the grander scheme of things. People generally compare digital realty with Google or Apple with AWS. They're not in the same line of business. Some of them are application service providers, while others are colo providers. While the reason Google builds data centers is not because they're in business of building data centers, it's because they cannot find anything to the size and scale and efficiency that they need. Otherwise, they'll be more than happy to outsource. Okay? So understanding where people are in this ecosystem, understanding where is a colo at the SFI layer, where is a managed hosting provider at the ITI layer, where you put your SLA. When you want to put a job ad, today if you want to hire a data center manager, if you want to hire someone to run your topology, your data center cloud, you need somebody who understands telecom and latency and weather forecast. Someone who would watch the Weather Channel every day and understand what is the impact of hurricane in site number 12 to the entire application ecosystem. Whereas if you want to hire someone to manage your data center node, that's one site. He should be someone who understands power, cooling, cabling, fire and safety codes. Totally different set of skill requirements. And with that said, I leave the rest to Steve.
Good afternoon. Kind of picking up on what you just said, recently I saw there were a number of job postings for data center engineers, right? And the data center engineering jobs, it was fascinating to look at the job descriptions, right? So you have, a data center engineering job being listed, and the qualifications for that job was that you must be a Cisco expert, you must have advanced knowledge of software-defined networking and all of this network infrastructure-related skills. Then another data center engineer job, and the skills required were cooling skills, mechanical engineering. So as an industry, we have this disconnect. We don't even really know what a data center is, right? Or at least everyone is taking that term and using it for their own purpose. So, Cisco will have us believe that the data center is the network, and to them it is, and that's a valid point of view from their standpoint, right? But Liebert believes that the data center is, the cooling and the power. It's a very valid point of view from their standpoint. But as an industry, we have to recognize that it's something bigger than that. It's something much, much bigger than that, right? And only then will we be able to really understand that we're operating within an application ecosystem. Our entire technology stack, as Mehdi had previewed, is working together in an interdependent and also an independent way. Right? We have the various technologies that are indicated in the pyramid that Mehdi displayed, which is this. All the various technologies that are at play within our data center environment are all interrelated. If we make changes in one area, it affects all of the areas. If we overbuild in one area, it will have an impact in some way or another on all of the various layers. If we underbuild a certain capability in any of the given layers, it will have an impact on all of the layers. And those impacts are actually measurable. And the thing is, and the real paradigm shift occurs when we finally realize, as an industry, that there is a way to measure that, right? And all of the measures that we've been engaging in so far have all been specific to a particular technical domain. If I talk about issues in the site facilities infrastructure layer, I'm going to be expressing my concerns in measurements that use kilowatts, or I'm going to be using other KPIs or other metrics that are specific to that technical domain. However, if I'm worried about issues in my network infrastructure, I'm not going to be talking about kilowatts. I'm going to be talking about gigabits of bandwidth and other measures that are of importance in that technical domain. And as an industry, we have failed to rationalize all of those into a common model, a common metric. And so that is what IDCA is all about. That is what the Technical Standards Committee has been working over the last 2 years to produce, is this model. So as you know, we've indicated the various layers, application platform, compute, information technology infrastructure, site facilities infrastructure, the site itself, and the topology. Of particular interest is some of the less obvious ones. When we say the site, what are we referring to? Well, we're not talking about the UPSs and the chiller plant. We're talking about the physical building itself, the land that it sits on. What are all the various concerns related to that specific geography and that area in terms of supporting a data center operation? What are the legislation? What is the laws? What are the tax impacts of running a data center in that area? What are the latency boundaries from a telecom standpoint for that particular location? All of these things are factored into the site selection process, typically in any given data center, but then forgotten quite soon after that process is completed. It's a very important component of our overall topology strategy to have an active and ongoing reevaluation of the suitability of given sites within our topology, right? As our needs evolve and so forth. That's just one layer. There are similar details in every one of these layers, and we could talk all afternoon about any given one of them. But what's really important is understanding, since we have all of these layers in our stack, the thing that makes them interdependent, the thing that makes them common to one another are these various efficacies, right? We have availability is a concern throughout our entire technology stack, right? So capacity management is a concern throughout our entire technology stack, as are these others. Operations practices, resilience, our disaster readiness and disaster recovery capabilities, as are our safety and security concerns, which are comprised of both the physical security elements that we put in place in our facilities, but also our logical security elements that we put in place to protect our data and applications from external and internal attack. And then, of course, we also have efficiency is a primary concern in our industry, and we're also introducing innovation as a factor in our overall evaluation of an application ecosystem. Innovation is very important, and we'll touch on that a little bit later. So the Infinity Paradigm model is the model to reduce business risk. And when I say business risk, I'm not specifically speaking to disaster events or other sorts of force majeure kind of scenarios. What I'm talking to is the risk associated with misalignment, the risk associated with overbuilding a data center facility at great expense because we don't properly understand the requirements at our application and platform level. The risk associated with having an inadequate understanding of our topology requirements from a business standpoint, and therefore selecting the wrong locations to put our data centers, or not properly understanding how our application design can affect our data center topology, right? I've seen scenarios where literally you can change a few hundred lines of code in a major production application, and that change in code actually negates the need to build entire data centers in the topology, right? So the potential for cost savings and the potential for misalignment or alignment based on how well you're attacking these efficacies is enormous. So we're providing a tool that allows businesses to do this kind of evaluation holistically, looking at their business requirements and then going down the entire technology stack and considering all of these various efficacies in order to properly, and for the first time really, fully view the entire technology stack as one single interdependent ecosystem, right? So the standards framework for the application ecosystem is a holistic and comprehensive framework of controls, guidance, and performance metrics. And the performance metrics are key. We'll touch on those a little bit later in the presentation. It's important to note, as Mehdi indicated earlier, the Technical Standards Committee that developed this is comprised of volunteers from every industry vertical, from every technology skill set, power guys, cooling guys, application guys, healthcare, finance, e-commerce, social media. Everyone is represented in this committee, and all of those points of view are represented in this committee. However, there are no vendors in the committee, right? And the reason is we wanted to develop a tool set that wasn't specific to a pre-prescribed solution, right? So we don't want to create a tool set that forces people into certain kinds of thinking, right? And that's not to, discredit or bash any particular vendor, because certainly those vendors will become part of the solution. However, if they're involved in designing the framework itself, naturally the framework will start to bend towards those solutions. And those solutions may not necessarily be the best choice for every single customer, right? So we've kept our committee free from vendor influence. However, the end user committee, the committee is completely dominated by end users, people that are actually working in the field every day on this stuff, solving problems as they arrive, encountering challenges, experiencing the pain of the demand for additional growth, experiencing the pain of the effect of misalignment, the effect of poor performance. These folks are living this at every level of scale, from small data center operators to very, very hyperscale data center operators. So how do we accomplish this? First, we establish what we call controls. Now, controls are, they're most concisely put, it's a measure that provides a reasonable assurance that a given component operates as intended. So it is a recommendation of a particular action to be taken related to a particular efficacy, related to a particular layer of the stack, right? So it's a recommendation for a certain outcome, right? Here's what you want at this layer for this efficacy for this particular area of concern, right? And it may be, a control may be specifying particular requirements for power, perhaps redundancy in certain components, but it also may be talking about controls related to security or operations or what have you. And so we establish these controls, and there are sub-controls to them as well, which you'll see in the Infinity Paradigm AE360 document. But these controls are at the heart of what we're doing in our model. So they ensure the necessary practices and processes are followed with sufficient rigor. And these controls also form the basis of the mathematical modeling that will ultimately result in a grade for the overall application ecosystem, which we'll discuss in a second. So that grade then informs management how well we're doing in the various areas. Those controls are largely derived from the competent guidance that the industry has already been following. The competent guidance of third-party standards bodies such as BICSI, ASHRAE, TIA, and all of the others who have been guiding our industry for decades. Each of them produce highly competent materials within their own technical domains. And if we layer them all together, right, and we take the guidance that's provided within those various standards or other documents produced by these various organizations and blended them together, what we see is they, for the most part, play nicely. However, there's still some gaps in between them, right? But what they don't do is they don't have an understanding of the areas that are outside of their technical domains, right? So they don't hand off and accept input from the other standards, right? So we have a standard for, how to build a particular facility type. We have a standard for how to do structured cabling. We have a standard for, various aspects of the data center environment. However, none of them are written with the understanding of how structured cabling impacts an application, right? Or an understanding of why we have a need for certain levels of redundancy in our medium voltage, layer within the data center site, and how that impacts the network, right? These standards are not designed, with that sort of holistic approach. They are all just centered on a particular technical domain, and they do that well, for the most part. Right? So, and we've been following those standards. So IDCA integrates the guidance from those standards into the framework, and that begins to form the foundation of the overall guidance that the Infinity Paradigm standards framework provides. We also integrate regulatory and governance guidance as well. Many of our companies are subject to some sort of governance or regulation, whether it be HIPAA, whether it be PCI, FedRAMP, et cetera. So as we are subject to these various regulations, the actions that demands on the application ecosystem will invariably affect the overall operation of that application ecosystem, will affect the efficiency of it, will affect the technology selections, and will impact various aspects of the overall application ecosystem. So what we do is we provide an integration of the controls that are required under these various regulatory and governance models and legislation. And that allows us to model within the framework the exact impact that those policies are having on your specific application ecosystem. Now, for the first time, senior level leadership within your organization not only understands that they are compliant with the regulation, but they also understand what the cost of that compliance is in terms of overall operational efficacy and efficiency, right? So they've been missing that view in the past. So now we can see it. So we've discussed already the various layers of the application ecosystem model include the application layer, the platform layer, the compute layer, ITI, SFI, site, and topology. One of the areas where folks that are just getting introduced to this tend to have a little bit of, well, hold on a second, doesn't compute mean computers? Well, not really, not in modern age. There was a time where that was true. Compute in the modern age is a reference to the virtual environment or the operating environment in which the application runs. The physical computers themselves are information technology infrastructure assets. So they live in the ITI layer. The site facilities infrastructure layer, as Mehdi revealed earlier, is primarily focused in power, cooling, fire suppression, and other physical attributes of the data center site itself. And then I've also already touched on the site and topology layers. Now, When we say we have efficacies of availability, capacity, operations, resilience, safety and security, efficiency, and innovation, some of these are obvious, right? Everyone here is concerned about availability, right? Everyone here has done some sort of capacity planning. Everyone here has been involved in the operations of a data center, more likely than not, been involved in the operations of a data center environment and been subject to operations policies, et cetera. So some of these are fairly familiar to you. I'm going to focus on one of them, innovation, right? So innovation is central to advancing into the next generation, right? If we continue, as Mehdi indicated earlier, if we continue to do things the same way over and over again, we will end up producing the same results over and over again, right? And the same results might have been good enough yesterday, but they're not good enough tomorrow. And so in order to get us to where we need to go, we as technology vendors, as end users, as organizations, everyone must continue to innovate. And it's never been more important because vendors tend to always innovate. They invent new products, they revise their existing products, and they do so based on what they think the market is requiring. But it's never been more important than it is right now as end users, as operators of data centers, for us to drive the innovation in the industry, rather than saying, okay, what's the next technology that's coming down the pike? Oh, that looks cool, let's buy one of those, right? And a lot of organizations get sucked into this concept of acquiring technology for the technology's sake, not because it is part of a holistic strategy to improve the operations of the business, right? Not because it meets some specific business requirement. Rather, it's just the latest version of the thing that we've been using, so we'll buy that version. Or rather, it's the latest trend in the development of data center facility construction, or it's the latest thing, so we just buy it because it's there, right? And that is sort of a vendor-led innovation strategy, right? We let the vendors tell us what we want. Again, no disrespect to the vendors, because they've been innovating and coming up with great products. And many of them are extremely well designed and have a very important purpose in our data center environments. But we are the end users. We are the operators. So we will need to begin to innovate much more so than ever before. We need to drive the designs. We need to tell the vendors what our businesses are really requiring. And the only way that we can do that is to provide to them some ironclad facts, some real measurements, and some real data that they can work with to provide solutions to meet the exact needs that our organizations are having. So one way that we do that is by providing a grading system. The grading system is part of our evaluation, where we go through and have the various controls that I mentioned earlier, and we evaluate an existing application ecosystem or a design of an application ecosystem. We evaluate where the various where the system itself actually performs in terms of these various controls, where we have deficiencies, where we are exceeding expectations, where we have an overabundance of capability, where we lack some capabilities, et cetera. So we grade that in each of the various layers of the application ecosystem. Whereas G4 represents the lowest level of compliance with the various controls that we measure. It's not the lowest possible level of compliance, but it's the lowest one that will register in our grading system. And then all the way up through the stack to G0, which represents infinite competency in all areas, right? And as Mehdi mentioned, we all recognize that infinity is not an achievable goal, but it is a goal nevertheless, right? We want to strive for the best performance that we can in most of our operational areas, or at least understand from our business requirements what our real targets actually are so that we can align everything in the stack against that. We also measure the capabilities that the application ecosystem has in regard to compliance with the various targets for these efficacies, the availability, capacity, et cetera. And we derive scores for that. So we have grade levels for our layers, and we have efficacy ratings for the various efficacies. And as you can probably start to picture in your head, we're creating a matrix here, right? And as a result, we end up with an overall score for the entire application ecosystem that represents its overall level of competency. This ESR score, or efficacy score rating, is a single number that represents to senior leadership and to stakeholders exactly how well that application ecosystem is performing against business requirements. So here's the matrix I spoke of. We see in this matrix the various layers of the application ecosystem along one axis, and we see the various efficacies along another axis, and then we have the various controls that exist within each of those cells within the matrix. Right, so if I look, I have a compute capacity, I have compute operations, I have ITI capacity, I have ITI availability, et cetera, and we have controls in each of those cells for each of those specific items, right? So in ITI capacity, I have a whole list of controls that are specifically designed that affect ITI capacity and my overall competency in that regard, right? And for each of the others as well. So, as Mehdi mentioned, the purpose of the data center is to deliver applications per the organization's demand. Data center is the infrastructure supporting the application ecosystem. So it's not a building, it's not a cooling center, it's not a powering center. So since the data center is the purpose, since the purpose of the data center is to deliver applications, and the data center itself is the infrastructure supporting the applications, then what is that building called? That building is actually a data center node, right? It's a combination of site facilities, infrastructure, and ITI supporting the application ecosystem at a specific location. And then the data center cloud, as Mehdi mentioned, is an arrangement of various data center nodes in a particular topology. So what are the benefits here? The Infinity Paradigm is a comprehensive, cloud-inclusive, efficiency-driven, and operations-conducive model. It is international in nature, yet localized. It's flexible, adaptable to specific environments. If you're not subject to Sarbanes-Oxley regulation, you don't need to comply with those controls that are related to that. And if you have complied with it, then you get credit for that within the paradigm. Vendor and technology neutral. It's an open, community-based effort. It's free. So how do I get it? The first step, as Mehdi mentioned, is education, right? So IDCA has already certified thousands of individuals on concepts surrounding the Infinity Paradigm. And there is a defined course curriculum available for professionals in every technical domain to become conversant in the application ecosystem concept, to be able to finally understand, I'm a power guy, and here's how my work supports the application ecosystem, right? It's not just about power, it's about everything, right? So, solving tomorrow's challenges requires a culture of innovation. I touched on this briefly earlier. A well-trained staff is exposed to many different technology and methodology alternatives can be an enormous resource. And I put in here a couple of my favorite quotes, right? So one is, most of us understand that innovation is enormously important. It's the only insurance against irrelevance. So irrelevance from an IT perspective is when your entire department gets outsourced to Amazon. You became irrelevant, right? there was a better alternative because you were not innovating enough within your organization to satisfy your organization's requirements. So how do we facilitate education? There's off-site public instructor-led classroom training. There's on-site private instructor-led classroom training and virtual training. There's various options, each of which have their own benefits and also one or the other may fit more aptly within your organization's needs. But some of the options present some benefits that may be specifically interesting to you. So, if my company is already has a comprehensive standards compliance program that includes ISO 27001, PCI, et cetera, and I'm Tier 4 certified, if I have all of this, why do I need something like the Infinity Paradigm, right? What's the benefit? I've already had this compliance program. Well, the fact is that having that compliance program is benefiting your organizations. You are reaping the benefit of conformance or compliance with those various standards, and they are improving your operations. However, that alone does not provide you with the comprehensive data-driven approach that the application ecosystem does. The standards framework integration provides invaluable benefits far and beyond that of just complying with any of the individual standards themselves. For example, KPI normalization. This is where we say, look, I've reached a certain PUE level in my data center operations at a particular site. Well, that's great. So I can take that number. Now, what does that tell me? What does that number tell me about my application efficiency? Well, it tells me nothing. But I have an application efficiency metric over here, and it's giving me a certain output. Well, how can I take those two and rationalize them together to form a complete picture of what my efficiency is all the way up and down my stack, right? Take all of the various metrics. Our model does that. I encourage you to look in at the documentation. You'll see some detail in regard to how that gets done. Implementing the IDCA Infinity Paradigm standards framework does not add more compliance challenges. It solves compliance challenges. It becomes a central point by which all of your compliance efforts can be managed and provides additional benefits above and beyond the compliance with the various independent standards by themselves. So we're not trying to diminish or discredit or somehow make useless any of the existing standards. What we're trying to do is provide a way to properly manage all of these various standards within a single framework and then provide the additional capabilities that individually they lack. So, various steps for integrating or for adopting the Infinity Paradigm. First, you would establish your business requirements. Then you would begin evaluating your infrastructure and applications using the controls in the Infinity Paradigm matrix. You would integrate the results of the third-party compliance certifications, for example, PCI compliance, et cetera, ISO compliance, into your results. You compute your scores and observe where the gaps and misalignments exist to determine courses of action for improvement. Use those results to innovate new solutions, and then model the proposed solutions to see their overall effect on scoring. So this is one of the greatest features of the entire model, is the ability to do what-if scenarios. What if I add a data center in Bangladesh? How does that impact my topology scoring, right? And we can do those what-if scenarios for any kind of improvement. So, Infinity Paradigm, free of charge. There's no cost from IDCA. Of course, if you make improvements based on the results that you find, there could be costs associated with those improvements that you would pay to the vendors involved in that, but that's not coming back to IDCA. So, in total, the Infinity Paradigm presents a significant advance forward in terms of the management of your application ecosystem, the ability to finally understand and recognize your application ecosystem as a completely interdependent model, and the ability to rationalize and utilize the KPIs that come out of your existing management processes in a manner that helps to inform you in a holistic and comprehensive way. That combined with the grading methodology that allows for vendors as well as end users to work together to achieve certain target outcomes. And you have a significantly improved model over what we currently do in the industry. So to circle back, who is IDCA?
It's an organization that's going to allow others to gravitate towards it, look for information, look for direction.
It is a focal point for data center management people like myself.
The goal of IDCA is to bring the future of technology in the data center forward.
Educate, provide standards to move people forward into that next level of operating and maintaining the data center.
IDCA brings together some of the top industry professionals.
They can meet and talk about the ideas they have or the problems they have and affect real change in the industry.
What we serve to do with IDCA and the Infinity Paradigm is to make people aware and see how important all of these holistic processes working together.
These are individuals who are in the cutting edge of data centers.
A cross-section of experts throughout the data center industry who actually work in the industry.
Individuals from LinkedIn, from eBay, from House of Representatives. It almost is like a think tank of all the top industry professionals that know about data centers that have all come together and really worked on what can we learn? What educational tools are we lacking? What certifications do we need? What standardizations do we need?
Sort of cross-knowledge, if you will, that's gained by this type of opportunity is invaluable in terms of educating not only the committee members, but the community at large.
If it stays on course and it continues on with the standards, I think the future is endless and the future is extremely bright. There's no particular body out there that's answering these questions today. And again, you can go back to all the standards bodies. Nobody is active in the community, and that goes back to your previous question. Why you have to have this community? Why you have to have like-minded people looking at technology and looking how you're going to evolve and move forward. And I think it's a fantastic future for the IDCA.
I'm Steve Nauman, and I'm a member of the IDCA Technical Standards Committee.
Steve Hambrick, Chairman of the IDCA Technical Standards Committee.
My name is Lance Walker. I'm a member of the IDCA Technical Standards Committee.
My name is Ashley Sharif. I'm legal counsel and a board member of IDCA, and I am IDCA.
I'm Eric Wendorf. I'm from LinkedIn, and I am IDCA.
I am IDCA.
I'm Bob Long, an IDCA instructor, and I am IDCA.
Hi, I'm Rick Collins. I'm from AIG. I'm the global head of data center operations, and I am a member of IDCA.
Hi, I'm Richard Zanata. I work for the U.S. House of Representatives. I'm the Director of Networking and Facilities, and I am IDCA.
Thank you for your time.
Steve, Mehdi, thank you very much.